Okay, so hi everyone. Today, as I mentioned yesterday, today we'll be doing the next part of the of this topic, which is Introduction to Algebra. So, have have you all heard of algebra? Learned anything a little bit about algebra or no? So, have you all learned or heard of algebra before? This topic? Okay, good. So let's begin with the definition of algebra. So we'll do definition first. So algebra is a branch of mathematics that uses letters and symbols to describe numbers. So here are some common terms that you want to memorize and understand before we begin. So first are variables. So variables are letters, so English letters like A, B, C, D, X, Y, Z, for example, letters that we use to represent unknown numbers. So if we have to represent something in mathematics and we don't know the number, then we'll use a variable. Okay, so the next term is a constant. So a constant is a fixed number that never changes. So constant can be any number like 2, 3, 100, 75, and so on. So these are numbers that will never change in mathematics. They will stay the same always. The third term is expression. So an expression is a phrase in mathematics that includes numbers, variables, and operations. So numbers are, of course, like 2, 7, 11, and so on. Variables are, again, unknown numbers as letters, so X, Y, Z, so on. And operations, which are plus, minus, times, division, etc. So an expression is kind of like a math sentence. So it's a mathematical phrase that consists of these things. And the last term is coefficient. Coefficient. Coefficient is a number that is attached to a variable. So for example, if we have 5x, 5 is the coefficient and x is the variable. So if we have something like this, 5x, the coefficient is 5 and the variable is x. And this means that 5 is being multiplied to x. So if we have 2a, it means 2 times a. If we have 7y, it means 7 times y. And both of these, 2 and 7, are coefficients. So does that make sense to everyone? Everyone is understanding. Good. So we'll look at this and we will determine the variables, coefficients, and constants. So the first thing is, what do we call this as a whole. We just discussed it in the last slide. So what is this called? Can anyone tell me? Does anyone remember? We just covered it in the previous slide. Anyone knows? Okay, that's okay. So, do you remember expressions? So, expression is, think of it as a math sentence. Expressions are phrases or sentences in mathematics that have numbers, variables, and operations. So, if you look here, we have numbers, we have variables, and we have operations. So, this is called an expression. Does that make sense to everyone? Yes, no. Everyone understands what expressions are?
Yes.
Good. Okay. So now let's go through each of these terms. So this is a term, this is a term, this is a term. So these are all called terms of our expression. Terms of the expression. So remember these terms that we just learned, the vocabulary words. So we have variable, constant, expression, and coefficient. So can someone tell me what do we call 3? What is 3 called? Correct. Coefficient. And then x is called what? Good job. And 8 is called what? Z or Z is what? Variable. And lastly, 9 is called what? So 9 is what? So remember, there's two terms. There's constant and there's coefficient. So 9 is a constant because there is no variable next to 9. It's just a number itself. So remember, constant equals just a number, and coefficient is a number and a variable. So this is very important to understand. Constant is just a number. Coefficient is a number that comes before a variable. So here there is no variable, so it is called a constant. So does that make sense to everyone? Does everyone understand this? Good. Okay. So now remember expressions. Expressions again are math sentences, so mathematical phrases. So there's two key words to understand. There is expression and there's also equation. And they're very similar, but they're very different. So think of expressions as mathematical phrases. Again, remember that word. Expressions are incomplete. So an expression could be 3x plus 7y. But think of equations as a mathematical sentence. So mathematical sentences are complete, right? A sentence has a subject and a verb and punctuation, so period or exclamation mark. So equations are complete. And what that means is that equations have equal signs and expressions do not. So if you have 3x plus 7y, this is an expression, right? Like we just discussed. However, if we have 3x plus 7y equals 10, this is then an equation, right? Because we have the equal sign. And an easy way to remember is that equation has EQ, right? It starts with the letters EQ, which is equals sign. So again, expressions have no equal sign and equations have an equals sign. So from here on, you can think of expressions as phrases and equations as sentences. Phrases are incomplete and sentences are complete. So does everyone understand that so far? Expressions versus equations. Yes or no? Okay, good. So the next thing we want to discuss is how can we translate words into operations? Remember, operations are like plus, minus, multiplication, division. So for example, if I were to tell you certain words, you should be able to understand those words and turn them into mathematical operations. So essentially, how do we represent expressions or equations with words? So these three boxes here will have some common words that represent these three common operations. So we have addition, subtraction, multiplication. So anytime you hear the word sum, more than, increased by, plus, total, all these words should signal addition. So every time you see these words, you should automatically in your head think of addition. Now, if you hear words like difference, less than, decreased by, or minus, these are all words that signal subtraction. And lastly, if you hear words like product, times, groups of, all these words should signal multiplication. So again, try your best to memorize these. You can watch the video on YouTube after the class. Make sure you memorize all of these words to be able to recognize addition, subtraction, multiplication from words. So you should be able to translate between English and math. So go from words to operations. So does that make sense for everyone? Yes or no? Yes. Do you need me to explain again or we're good? Okay. And yes, if you need to see these words one more time, then you can see the video recap on YouTube after the class. But make sure you memorize and understand all of these terms. So now let's do an example. So if your teacher, for example, was to say this sentence to you, you should be able to turn this into an equation. So we'll start with each of the words. So the total of an unknown number and 3 times 6 is equal to 36. So let's see the first word. Total is what? Addition, subtraction, or multiplication? Addition, correct. An unknown number is what? Variable, correct. 3 is what? Constant, correct. Times is what? Addition, multiplication, or subtraction? Correct. And 36 is what? Constant. So I heard some people say coefficient. Remember, coefficient is if there is a variable attached. So remember, 36 here is just the number. There is no variable, so it's a constant, not a coefficient. So now let's turn this into mathematical terms. So first we have to recognize, is this an expression or an equation? Can anyone tell me? Equation, correct, because we have an equals sign. Remember, equation is with an equal sign, expression is no equals sign. Okay, good job. So now let's look more into our terms. So we know total, so we know we are adding two terms together. And what are the two terms? Well, the first term is the variable, the unknown number, and the second term is 3. So 3 is the second term. So we have to add these terms together. So remember, variables are letters, so we can choose any letter we want. So for this, I will use, let's say, the letter K. So this is our unknown number. So this is the first term completed. So K plus 3, that's our second term completed. Now, what else do we have? We have times 6 and equal to 36. So we'll add our equal sign to make it easy, and we'll add our 36. So everything on this side of the equation should be equal to 36. So we have the total done, we have the unknown number done, and we have 3. So lastly, we have to multiply 6. But can anyone tell me, is the 6 multiplying the 3 only, or is it multiplying everything? Does anyone know? Are we multiplying everything by 6, or are we multiplying only 3 by 6? Okay, so let's see how can we know from the sentence whether to multiply everything by 6 or to multiply only the 3 by 6? So notice how the times 6 is here, right? And it comes after the total. So we're saying that the total of the unknown number and 3, so this is our total times 6. So this means we have to apply the multiplication to everything. So the unknown number and 3 as well. If it were to say, the total of an unknown number and 3 times 6, notice there's no comma, then in this case, we will multiply only the 3 by 6. So when you're reading these sentences, it's very, very important that you pay very careful attention to punctuation and all of the components of your sentence. So since we have that comma there, as I just explained, we'll have to multiply everything by 6. So we'll do exactly that. We'll multiply everything by 6, and this is our final equation. So does this make sense to everybody, or is there any confusion? Everyone is understanding, or is there any doubts? Yes, everyone is understanding? Okay, good. And remember, if you have any doubts, you can rewatch the video on YouTube afterwards. So the next thing we'll learn is how to actually evaluate expressions. So how do we solve expressions? So there's three main steps. Three main steps to evaluate expressions. So the first step here is to replace the variable with the number you are given. So for example, if you have an expression like 3y plus 81, you'll be told, okay, y equals 7 or y equals 6. And then that can then be replaced by the variable, with the variable. The second step is to follow the order of operations as you normally would for any mathematical operations. So that would be through these acronyms, BODMAS or PEMDAS, whichever one you've learned in school. And then the last is going to be, of course, finding your final value. So everyone understands the BODMAS PEMDAS order of operations. Everyone understands. Yes? Or have you learned about order of operations or no? Yes. Okay, good. So let's see an example then. So we want to evaluate 2x plus 3 when x equals 5. So first, I want to ask you, is this an expression or an equation? Expression, correct, because there is no equals sign. Good. So remember, the first step here was to replace the variable with the given number. So the given number is x equals 5. Remember, x is our variable. So we'll replace the x with 5. So we go from 2x plus 3 to 2 times 5 plus 3. And then from here, it's pretty obvious. We'll follow the order of operations. So we'll do multiplication first before addition. So we'll do 2 times 5, which is 10, plus 3, and our final answer is 13. So very simple. All you have to do is replace your variable with the value given to you, and then evaluate the expression as normal. So using one of these acronyms, whichever one you've learned. So does that make that makes sense for everyone? Everyone is understanding that? Good. So we have just a little bit of time left. So let's see this next topic. So combining like terms. So far, all of the expressions or equations I have shown you have been pretty simple, right? We've just done things like 2x plus 3, um, 3y plus 7, and so on. So very, very simple. However, what happens when you have a longer expression? So let's say you have 5x plus 7y plus 8z plus 11x plus 36 plus 18y and so on. So what do we do if we have such a big or long expression? So this is when we have to understand the concept of like terms. So remember, this is a term, this is a term, this is a term. So all of these pieces are terms of the expression. So there's two types of terms. There are like terms and there are unlike terms. So like terms are two terms of the expression that have the same variable. So for example, 3x and 5x are like terms because they both have the same variable, and therefore we can combine them like normal. Unlike terms, for example, 3x and 5 are not like terms. They're unlike terms because one of them has an x and one of them is a constant. Remember this vocab word, constant. So therefore, we cannot combine them. So let's see in this expression example I've given. So let's look at the first two terms. Are these like terms or unlike terms? Unlike terms, correct. Because, yes, they both have variables, but they're not the same variable. See, this one has an x and this one has a y. So we cannot combine them like this. However, 5x and 11x, are they like terms or unlike terms? Correct. These two are like terms because they both have the variable x. So we can combine them like we normally would. 16x. So 5x plus 11x would be 16x. Simply add the coefficients, 5 and 11. So does this make sense for everyone? Understanding like and unlike terms? Yes or no? Good. So let's see. Okay, let's finish this quickly. This will be the end of today's class and also the end of the introduction to algebra. So the last concept here is finding variable values. So sometimes you'll be given a value for x, so or for any variable. So you might be given x equals 5, y equals 10, z equals 8, for example. So sometimes you'll be given those numbers, but sometimes you will be asked to find it yourself. So for example, let's say we have the equation 2x plus 10 equals 20. We want you to find the value of x that makes this equation true. In other words, what does x need to be? So what does x have to be as a number in order for 2x plus 10 to equal 20? So this is when we use something called inverse operations. So addition and subtraction are inverts, and multiplication and division are also inverses. So the inverse of addition is subtraction, and the inverse of subtraction is addition, and the inverse of multiplication is division, and the inverse of division is multiplication. So let's see an example on using these inverse operations. So let's try to solve this equation. We have 2x plus 10 equals 20. So we want to find x. So what is x equal to? So 2x plus 10 equals 20. We have to do inverse operations. So the first step is to isolate any terms with variables. So isolate means to bring it alone. So essentially what we want to do is have the variable expression, so the variable term by itself. So we don't want anything else on that side. So what we need to do is bring the 10 over to this side. And how do we do this? We do it through inverse operations. So this is addition, right? What is the inverse of addition? Subtraction, correct. So we will subtract 10 From both sides of the equation, we'll subtract 10 because that's the inverse operation. So if we do that, we get 2x plus 10 minus 10 equals 20 minus 10. So 10 minus 10 is, of course, 0, and 20 minus 10 is 10. So our new equation, right now is 2x equals 10. So lastly, we have to perform any remaining inverse operations to get x, right? So remember, we want to find x. So what operation is this? 2x is what operation? Addition, subtraction, multiplication, division, or what? Multiplication, correct. So we'll do the inverse, which is division. So we will divide both sides by 2. So we'll do 2x divided by 2. Remember fractions we just discussed yesterday. Fractions are division. So 2x divided by 2 equals 10 divided by 2. So of course 2x divided by 2 will just be x, and 10 divided by 2 is 5. So eventually we will reach the conclusion that x equals 5. So what value of x makes this equation true? Well, the answer to that is 5. And we can check our work by plugging 5 back in. Remember, some of the problems we saw earlier was it gave you the value for the variable, and you simply replace the variable with that number. So we can do a similar thing to check our work. So we'll just plug 5 back in. We'll do 2 times 5 plus 10 equals 20. And we'll say 2 times 5 is 10 plus 10 does in fact equal 20. So our work was correct. So eventually x equals 5. So does everyone understand this? How can we find variable values from an expression or equation? Does everyone understand? Yes or no? Okay, very good. So that is the end of today's class. So again, today's class was an introduction to algebra. So that's what we covered today. And we covered all the vocabulary. We covered expressions, equations, how to evaluate expressions, and how to use variables. So hopefully you learned something. And if you have any doubts, you can watch the video that I'll upload again. But thank you very much for having me. And I'll see you in the next class.